Hi everybody, today we're going to have a look at polygons and see how we can use them for problem solving. So a polygon is a closed shape with straight edges. Just to make sure we know the difference between an open shape and a closed shape. That's open because we can get to the center of it. This one is closed. It's not quite a polygon because it doesn't have a straight edge here, but I'm sure you get the idea. There's no way that we can get inside this shape from the outside because it's closed off. So it needs to be closed and the edges have to be straight, much better than I can freehand. When we name a polygon, it's named by the number of sides that it has. Where two sides meet is called a vertex. And the lines that connect the vertex are called edges. So in this case, if we have a three-sided shape, it would be a triangle. A four-sided shape would be a quadrilateral. Pentagon, hexagon, heptagon, octagon, nonagon, decagon, hendecagon or undecagon, and dodecagon. And you pretty much have to learn those off. They are very handy, and you don't probably have to go much further than 12. 12 is usually sufficient. Then we have some definitions of different types of polygons. So a regular polygon has all sides of equal length, and if we have a length of equal side, we mark it with a little line, and that tells us that that's the same length as that, it's the same length as that, it's the same length as that, it's the same length as that. They're all the same. It's regular. And a regular pentagon would have sides of different lengths. So this side is obviously longer than this side. It's an irregular polygon. A convex polygon has all internal angles less than 180 degrees. And in this regular pentagon here, we can see that all of the angles are less than 180 degrees. And in fact, because it's regular, they are also all the same size. They are equiangular. Now, if we have a look at our second case here, this is a concave polygon, and it has an angle greater than 180 degrees. In fact, it's this angle here at D. Every other angle is acute. Oh, this one, yep, no, it's not acute. This one's obtuse, but it's still less than 180 degrees. This is our first reflex angle. So if we were going to name these polygons, we name them with capital letters at each vertex and either go clockwise or counterclockwise or anticlockwise. So if we start at H, I, J, K, L, we've gone clockwise. In this case, we've gone A, B, C, D, E, anticlockwise. So we could name this first polygon a convex pentagon, H, I, J, K, L. And in this case, we have a concave pentagon, A, B, C, D, E. A diagonal connects two vertices, dividing a shape into parts. So there's one diagonal, here's a second diagonal, here's a third diagonal. It's divided into four different parts. This line here is not a diagonal because it doesn't divide the shape into parts. The internal angle of a regular polygon can be found by making isosceles triangles. So if we had a hexagon, which we have here, and I divided it into 6 even triangles because it's a regular hexagon. This angle here in the middle would be 360 divided by 6, which is 60 degrees. If we've used up 60 degrees of this triangle up here, we have 120 degrees to divide between the two base angles of the isosceles triangle formed, which would mean that each one has to be 60. And if we want the internal angle of the hexagon, it's this one plus the adjacent angle here of the adjacent triangle. That'd be 60 plus another 60 would be 120 degrees. If we're wanting to lay that out, we could lay it out like this. The angle at the apex of the isosceles triangle is 360 divided by 6, which would give us 60 degrees. The total of the base angles would be 180 take 60, and if we want a single base angle, we'd divide that by 2 to give us 60 degrees. Should really fix up my working here. It's a bit untidy. The internal angle itself is twice the base angle, which is 60 times 2, which is 120. And if we want to know the total of all of the internal angles, we've got 6 of them, 1, 2, 3, 4, 5, 6. So multiply 120 by 6, and I did this by doing 100 times 6 plus 20 times 6, which gave me 720 degrees. So there we go. A bit of looking at polygons. a seemingly simple topic until you start digging into it, and there's a fair bit in there definitions-wise that you have to learn off. So I hope that helps, and I'll see you all soon. Thank you.